Okay, we're going to start with exponential functions. An exponential function has a base that's a 2 or a number, and the exponent's a variable. So 2 to the x, e to the x, 3 to the x. These are all exponential functions. So if you were going to test it, and you could use your calculator to figure this out, is that you could say, this is 2 to the x. It's always going to go through 1 because when you put 0 into the exponent, 2 to the 0 is going to be 1, e to the 0 is going to be 1, 3 to the 0 is going to be 1. So if you were to put in your calculator the derivative of 2 to the x, it'll go straight through like this, but it'll look a little bit below it. And so that means that, notice how it's still an exponential, that there has been a vertical shrink. It still looks the same, but there's a vertical shrink. So if the original function is f of x is equal to 2 to the x, then the derivative of it is going to be the same thing. It's still x on there. So we have 2. So we have 2 to the x is still going to be the same 2 to the x, but it's been stretched or shrunk. In this case, it's shrunk because it's below. So when we shrink it, that's going to be shrunk by ln of 2. How do I know this? It's because if you actually investigated into the calculator, you're going to see that it's been shrunk by 0.693 on there. And the ln of 2 is actually the same number. So just through the investigation that we did in class, you could see that that's the same thing that we're going to get. So the main thing you have to know is that it's going to shrink by that. And the reason why it's shrinking is because the ln of 2 is smaller than 1. E to the x, if we remember from the beginning of the semester, we've actually inputted and found all the slopes, the tangent slopes of e to the x. So when we realized that, we said that the derivative of e to the x is going to be exactly the same e to the x because they share the same tangent slopes. So that means that if I were to graph that, if this was e to the x, then the derivative is exactly the same. It's going to be right on top of it, which makes sense because this was a shrink. And if we were to use the rules of it stretching or shrinking, that means that the derivative here is going to be e to the x. And I have to do the stretching, so it'll be ln of e to the x. But we know that they have the same base. Anytime that they have the same base, it's going to be 1. So there is no stretch or shrink because the ln of e base e is going to be 1, so therefore it's e to the x. So algebraically, we did it using our calculator, and this is the information that we investigated using our calculator. Now, what's happening to the 3 to the x? Well, if we have, when we look at this, if we have the derivative of 3 to the x, that means that it's still going to be stretching or shrinking. So it's going to be ln of 3 times e to the 3 to the x. And when you do that, what is this number? Is it going to be a stretch or is it going to be a shrink? And what it turns out is that if this is e 3 to the x, then this one right here is going to be just a tiny bit above it because the ln of 3 is actually 1.09 dot dot dot, and so it's just going to stretch a little bit. So that means that ln of 2 is a shrink because it's below, and then it goes to 1, and then it goes above, and anything above ln of 3 is going to be a stretch. So anytime you're taking the derivative of an exponential function, it's always going to be the actual exponential function, and then it's either going to be stretched or shrunk. Most of the time, it's probably going to be stretched for any number greater than 2.7. 3 and bigger, it's always going to be a stretch. So that's how you take the derivative of an exponential function. A natural log is much easier. A natural log is always going to be while the exponential function has natural log in the derivative, that is not derivative of a log function. We use ln to find the derivative of an exponential function. But the actual derivative of a log function, the natural log function, is that you need to know that this here is going to be an argument. Anytime you have ln and whatever's after it, it means that that's the argument. So it's going to be ln of x is the argument. The derivative of, so if I have this to be my function, the derivative of ln of x is going to be 1 over the argument. So in this case, it's x, so it's going to be whatever this is going to be in the denominator. And then the tangent and the trig function's derivatives is that the derivative of sine of x is going to be cosine of x. And notice how what applies to ln to be an argument, the x is also an argument, and this x is always an argument. That's why we've always said that sin is not a word, but x now becomes sine because it's missing the argument. The derivative of cosine of x is going to be negative sine of x, and the derivative of tangent of x is going to be secant squared of x. And so those are the derivatives of sine and cosine, and the exponential and the natural log.